2017 question 12. Which of the following molecules is polar? So to know if a molecule is polar or not, we need to know its shape and see whether the bond polarities can cancel out or not. First one, CO2. Now, I suggest you for the more common molecules like CO2, H2O, and of course BF3, PCl5, SF6. These three are obviously explicitly mentioned in the DSE syllabus, but those like carbon dioxide, water, NH3, ammonia, these are also quite often asked in the past papers. So at least be familiar with their shapes as well. So CO2 has a linear shape. So linear shape would look like this. And the bond polarity, oxygen is the more electronegative atom. So the bond polarities would be facing towards its direction. Obviously, they're in opposite directions, so we can cross them out. We can cancel them out. That means this is non-polar. So option A is wrong. PCl3 here, we have phosphorus having 5 outermost electrons. And you'll notice that if you know its shape, 2 of the electrons are lone pairs, and the rest of the 3 electrons will be shared each with one of the chlorine atoms. So here you have PCl3. Chlorine is the more electronegative atom. So the bond polarities would be facing downwards, and you'll see overall you have, for the overall molecule, the polarity would be facing downwards. So it's polar. So actually the answer is B. But the other two, now SiF4, this is having to help you a bit also, if it ends with 3, the last atom ends with 3, the shape would be trigonal planar unless they're a lone pair of electrons. Like here, they're a lone pair of electrons, so it's not trigonal planar anymore. It becomes this shape becomes trigonal pyramidal. Because as I said, they want to be as far apart as possible, and because of the repulsion from the lone pair of electrons, the shape changes a bit. SiF4, this is a tetrahedral shape. So it will look like this: Si, F, 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 F. Now there's a common misconception that if it's tetrahedral, then it's gonna be non-polar. Now there are some exceptions to it, like I can think of trichloromethane, CHCl3. That's another tetrahedral structure that's quite commonly asked in the past papers, but that one is polar actually. So here, the best way to do it is always to write these bond polarities and see whether you can cross them out. Fluorine obviously is the more electronegative atom, so bond polarities will be facing that direction. Now the ones at the bottom here, you can say the overall bond polarity for these 3 are facing downwards, and then the last 2, one is facing upwards and one is facing downwards, then you can cross these 2 as well. So obviously this is also non-polar. And the last one, if the last atom ends with 6, obviously then we say that this is octahedral shape. And for SF6, as I said, this is one of the more common ones that's explicitly mentioned. This is obviously non-polar as well. But to draw it for you, SF6, SF, maybe I'll draw the dotted one here, it's easier. Okay, now all of them, you'll notice that they also cross out with one another, their bond polarities, because fluorine is the more electronegative atom. And they're all in opposite directions. Those in opposite direction, cross them out. You can cross them all out. That's why this is also non-polar. So the only answer here is PCl3.